Please read the question, draw the diagram, and then verify it with my diagram. I hope you guys have tried it. So what they have given is, we have a circle. Let me copy this. Okay, so if two equal chords of a circle intersect within the circle, so what they're telling is we have two chords and they are intersecting, means they are cutting each other at a particular point, maybe not at the center, no, at a random point. So if this is AB and PQ, these are two equal chords and they are meeting at say M within the circle, right? So you can see these two chords are meeting or cutting each other within the circle at a point M. This is O. Prove that the segment of one chord are equal to the corresponding segment of the other chord. So what does that mean? Well, we have to prove that AM is equal to MQ and MP is equal to MB. This is what we need to prove. As simple as that. So how do we do this? Well, I'll give you guys a clue. Draw a perpendicular line to both the chords. That's your clue. So these are perpendicular. So let's name them as E and T. And one more clue is you need to join OM. Now think about how to go about proving this. Okay, let's begin with talking about, let's consider a circle with center O. Then what do we have? Then we have, then what else we have actually? AB and PQ be the two equal chords intersecting each other at M. Right? And what else? Then we have to prove. So what is that we need to prove? AM is equal to MQ and PM is equal to MB. This is what we need to prove. So proof. How will we go about proving this? First thing first, drop OE perpendicular to AB and OT perpendicular to PQ. So they act like perpendicular bisector actually. Anyways, that we'll talk about later. So with this in mind, can we go about proving this? Think about it. Well, we can actually consider. So this can be construction actually. Let me not write it as proof. We will write it as construction. Okay. So this is your construction. So what did we construct? This. Now the proof. Proof. Consider triangle OEM and OTM. So please think over. How can we prove that these two are congruent? Obviously, if I take two triangles, it has to do with congruency only. So how do you prove that these two are congruent? To begin with, OM is common, right? Okay, then angle OEM, which is equal to angle OTM, this is equal to 90 degree. Reason being the construction. Right? You can refer construction, you will understand. Now I'm going to tell OE is equal to OT. Why is that? Perpendicular distance to equal chords from the center of the circle of a circle will be of equal lengths. So the theorem tells that O, right, OE is equal to OT. Now with this in mind, what can we conclude? Therefore triangle OEM is congruent to triangle OTM. How can we tell this? With the help of RHS, is it not? Right angle, this is our hypotenuse OM, and this is our side with help of RHS congruency. So how will this help? Well, this will help us to prove that EM is equal to MT. That's nothing but your CPCT. Okay, so EM is equal to ET. What next? We have to prove that AM is equal to MQ and PM is equal to MB. How will we prove now AM is equal to MQ? Think about it. Well, we can do it this way. So first, let's begin with the fact that AB is equal to PQ. This is given. Now we are going to dividing 2 on both the sides. On both sides. So what will we get? We have AB by 2, which is equal to PQ by 2. But AB by 2 will give us AE and PQ by 2 will give us TQ. Why is that? Because a perpendicular from center to a chord bisects the chord. Right? So we have AE is equal to TQ. Now if we add 1 and 2. So if we add equation 1 and 2. So adding equation 1 plus equation 2. What will we get? We get EM plus EA, which is equal to MT plus TQ. So ME plus EA will give me AM, right? So this will give me AM and MT plus TQ will give me MQ. So first part is proved. Now on to the next part. So AB is equal to PQ. This is given. Now what we'll do is we'll call this as 3. We will subtract. We will subtract 3 with 4 actually. So if I subtract AB with AM and if I subtract PQ with MQ, what will we get? Have a look. So if I subtract AB with AM, I'll get MB. And if I subtract PQ with MQ, I'll get PM. And we have proved the required. That's it. Okay. So you can see the whole of geometry is kind of continuous. Theorems from previous chapter is carried over. Properties from previous chapters is carried over. All of the things have to be concrete before you move on to the next chapter. That's why people tell geometry is tough, because of this very reason. There's a lot of theorem not lot actually. There are few concrete theorems that we need to carry over to understand and do new questions. There's a lot of writing also, so put together the topics are tough. So please learn properties as and when you move across. Just don't learn only the answers. Learn properties, because when you get a new question, you should be able to apply those properties. Please learn this way. So now pause and have a look at the answers.